Good morning, everyone. Wow, this is a wonderful audience. It comes to attention very, very quickly. Given that this is an Arctic meeting, we're supposed to have snow tomorrow, so just be patient. You know, just one more day. Very warm welcome to all of you. My name is Kenneth Yalowitz. I'm the director of the Dickey Center for International Understanding here at Dartmouth. And it is really both a pleasure and an honor to welcome you here. I think, you know, those of you who've arrived already and have been at various meetings have been in our new Haldeman Center building, the new Dickey Center. And it's really fitting. This is a brand new building, and this is the first major international conference that we have held in the new building. And I can't think of a more important, a more timely subject than the Arctic and climate change. So we are really very delighted to have you here for this very important meeting. The ASSW 2007 here at Dartmouth is being co-sponsored by the Dickey Center for International Understanding and our Institute of Arctic Studies, but also with the United States Army Cold Regions Research and Engineering Laboratory. We have a very close collaboration and cooperative relationship with CREL, and it's something that both institutions are very proud of. And the two people who were most responsible for organizing this meeting, one each from one each of the two organizations, I would like to acknowledge now for their absolutely wonderful and very successful work together. First, Professor Ross Virginia, who is the director of the Institute of Arctic Studies, which very happily is part of the Dickey Center, and Mary Albert, senior research engineer at CREL, and I would like them both to stand and be recognized. The Dickey Center, I think probably all of you have received our 25th anniversary pamphlet, so I'm not going to go into a great deal of detail. But our basic mission here at Dartmouth is to promote international understanding and to focus on the great issues of our time, and to be sure that our students, faculty, and community members have a good understanding of those issues. And also, very importantly, in my judgment, a commitment to do something about them. And without any doubt, the whole issue of the Arctic and climate change, global warming, we have defined as one of the most important issues on our program of activities for at least the next 5 years, and I'm certainly going on, well beyond that. What we try to focus on is examination of issues very much on an interdisciplinary basis, and that's very much the basic approach that we're trying to use in approaching global warming. And I'm very happy today to welcome you to Science Day. This is really the first full day of the ASSW meeting in plenary session. I think we're going to find today a great deal of very useful and innovative information about scientific programs and issues in the Arctic, and even more so because this is linked with the IPY. I would now like to invite Dr. Jackie Richter-Menga, who is the technical director of CREL, to welcome you as well. Jackie?
Thanks. I am so pleased to be here on behalf of the United States Army Corps of Engineers, Cold Regions Research and Engineering Laboratory, to welcome you to the Arctic Science Summit Week Science Day. I also would like to acknowledge the efforts of Mary and Ross and Ken. I remember you there at the breakfast table in the first mornings that we were talking to this. I think this is a big enough event they should get a second round of applause. Congratulations. I would also like to extend thanks to Ann Udry, other members of the Dartmouth staff, and the students responsible for facilitating this meeting. I've seen a lot of happy faces behind the desk, and I think it's spring break here too, isn't it? So they're here despite having potential vacation times in Florida, so thank you as well. There are a number of reasons why CREL is particularly pleased to be hosting this meeting in partnership with Dartmouth College's Institute of Arctic Studies. First and foremost, there's the science. When it comes to cold region science and technology, CREL's roots run deep. We trace our lineage back to the 1945 establishment of the Permafrost Division located in St. Paul, Minnesota, with a field office in Fairbanks, Alaska. The Permafrost Division was established in response to challenges faced during a period of rapid expansion in the Alaskan infrastructure during the early 1940s. Specifically, it was during the construction of the Alcan Highway that the U.S. government got its first taste of building roads in permafrost-rich ground, and it wasn't a pretty picture. Quickly realized that a group dedicated to developing engineering technologies for the polar regions was in order. Based on firsthand experience, CREL understands the importance of basic and applied scientific research in developing effective solutions to pressing scientific, engineering, and societal concerns. Seeing this approach echo repeatedly in the organizational activities of this meeting leaves us confident that the results of our collective efforts will be of significant benefit. The specific effort to involve students and early career polar scientists and engineers in this meeting further encourage us to believe that the impact of our efforts will be long-lasting. A venue that aggressively promotes teaming across disciplinary, agency, and international boundaries is also to our liking. A quick glance at today's agenda demonstrates a commitment to work together in solving problems of significant concern to the global community. Finally, our partnership with Dartmouth College in organizing this meeting is, as my daughters would say, particularly sweet. No doubt those who had the foresight and determination to locate CREL within a few miles of Dartmouth are smiling down on all of us today, working together to facilitate a meeting that provides a forum for wide-ranging discussions among scientists and administrators with a keen interest in the polar regions is, I expect, exactly what they had in mind. For these reasons and many others, CREL is privileged to welcome you to Hanover for this inaugural event of the International Polar Year, extends our best wishes for a productive meeting. Thank you.
And now it's my pleasure to introduce Dr. Barry Scherr, who's the provost of Dartmouth, who will introduce our very distinguished opening speaker. Barry?
So again, on behalf of Dartmouth College, it gives me great pleasure to welcome all of you to the events of the Arctic Science Summit Week, and specifically to the panel and to the talks that are part of Science Day today. Now, yesterday, as I mentioned to a few of the people who are in this room, Dartmouth has really had a long-standing interest in and commitment to Arctic studies. In part, it grows out of our geographical location, which is relatively northern within the U.S., though as I particularly learned yesterday that compared to where many of the participants in this week's activities come from, it's kind of on the southern edge of what people regard to as the north, almost deep south it felt like at times. But our commitment really extends really far beyond that. And we want to expand on Ken's earlier comments about the Dickey Center. Really, the Dickey Center has been home to the Institute of Arctic Studies since its origins, nearly, well, actually, now it is exactly 25 years ago. And throughout that time, Arctic studies have been one of the real focal points of that center. And that center really has had its particular focus, which in a sense reflects the commitment of the president of Dartmouth, for whom it is named, John Sloan Dickey. When Dickey came to Dartmouth, this is really just right after World War II, he became president in 1945, served until 1970. Dickey really did not have experience in university administration. He was, in fact, a very young rising star in the State Department. His field was foreign affairs. And when he came to Dartmouth, he recognized that Dartmouth was a school that had a role to play on the world scene. And he did a number of things to advance that. I won't go into all of those right now. But I will point out that one of the things he realized is that Dartmouth was not always taking advantage of that geographical location, not paying sufficient attention to Canada and to its position in the north. And it was no doubt, as a result of that those teachings by Dickey, that when the center was formed, Arctic studies became an integral part of it from the very beginning. And recently, under the leadership of Ross, Virginia, the Arctic Studies Institute has really become even more active than before. There's more than 15 faculty members who are associated with the Institute. They represent a wide range of departments, ranging from environmental studies to anthropology, earth sciences, engineering, geography, linguistics, physics. And of course, there is the active collaboration with CREL and with other agencies and entities that extend beyond Dartmouth. And I really need to add that one of the aspects of Dartmouth that make it a real home for Northern studies is the Stephenson Collection on polar exploration. Originally founded as a private collection, since it came to Dartmouth, it provided our library with an exceptionally rich body of material for research on the Arctic and on the Antarctic. It is really one of the world's premier collections on polar exploration and attracts scholars from around the world to its rich materials. Well, my main duty this morning is simply to introduce our speaker, Dr. Arden Bement, Director of the National Science Foundation, who will be giving the day's opening remarks. Dr. Bement has had a highly distinguished career in 3 worlds of research. He has moved back and forth between these worlds with remarkable adaptability, and I must add, with remarkable success as well. First of all, industry. He served as a senior research associate at General Electric for roughly a decade, near the beginning of his career. Later, he was manager of 2 departments at Battelle Northwest Laboratories, and still later served as vice president of technical resources and of science and technology at TRW Incorporated. Second, in the world of academia, he has been a professor of nuclear physics at MIT and at Purdue University, where he still holds the title of Distinguished Professor of Nuclear Engineering. He headed the School for Nuclear Engineering and also held appointments in 2 of the other engineering departments as well. And the third world is that of government. He directed the Office of Materials Science at the Defense Advanced Research Projects Agency, DARPA, and went on to serve as Deputy Undersecretary of Defense for Research and Engineering. And then, really, some 2 decades later, he was called back to government from his duties at Purdue to serve as the director of the National Institute of Standards and Technology. Then in February of 2004, when the directorship of the NSF became vacant, he was asked to serve as acting director of that agency while continuing to head NIST, which itself, I must add, is a very large agency. And in fact, it was shortly after that that he came to Dartmouth for the first time for a visit, and probably, I guess, not really coincidentally, but in fact, one hopes it's not coincidentally, people recognize his astute judgment in coming here, and then shortly afterwards, he was named director of the National Science Foundation. As head of NSF, he oversees an agency with an annual budget of nearly $6 billion, which is used to fund about 20% of all the federally supported research at colleges and universities throughout the United States. Its mission is to further an integrated strategy for advancing the frontiers of knowledge. And it does this in large part by making approximately 10,000 new grants each year in science and engineering, by funding the purchase of major research equipment, and by supporting science and engineering education from the preschool years through graduate school. Thus, the directorship of NSF is a vital position for the entire research effort in the United States, and it is reassuring to have such an accomplished individual at its helm. Please join me in welcoming Dr. Bement to open our Science Day program.
Thank you, Dr. Scherr, for that wonderful introduction. Sometimes I think it's more of a eulogy than an introduction. And perhaps I should also say spasibo. Good morning, everyone. I am delighted and honored to be able to address this distinguished international audience and I'd like very much to thank our Dartmouth hosts for their wonderful hospitality. Let me begin by mentioning that the National Science Foundation supports extensive programs of research and education, both in the Arctic and in the Antarctic. The current Arctic System Science Program dates from 1989, but NSF has supported studies in the Arctic for nearly its entire 50-year history. As a matter of fact, it was 50 years ago, almost exactly during the International Geophysical Year, that we established our McMurdo base in the Antarctic. NSF also provides major support for climate change research throughout all disciplines and with many international partners. NSF is also the lead agency for International Polar Year activities in the United States. Our role is to work closely with other U.S. agencies and other nations worldwide to achieve the vision articulated by the International Council on Science and the World Meteorological Organization, and here in the U.S. by the National Research Council of the National Academies of Science. The National Academies report lays out the U.S. vision for the International Polar Year. And just as Mary Albert has her fingerprints on a lot of things here having to do with the Arctic and cold regions, she also played a guiding and informing role in putting out this report. Thank you, Mary. The report contains sweeping goals to which many U.S. agencies will contribute, individually and collectively. It reflects a superb understanding of what we need to accomplish and sets out a clear path to progress. However, the true potential for progress in Arctic studies lies in joining together as international colleagues to confront the major challenges we face in the polar regions. For all of these reasons, I consider the Arctic Science Summit to be of extraordinary importance this year. NSF, together with our colleagues from other agencies, has a big stake in Arctic science and education. I have no doubt that is mirrored by the importance every one of you places on these issues. IPY provides an opportunity to focus worldwide attention on the challenges of understanding the system-scale environment and environmental challenges now observed in the polar regions. Perhaps more importantly, IPY has the potential to generate a concerted worldwide effort to move forward in resolving those challenges. We will need the highest levels of international cooperation among scientists, educators, and decision makers to realize this ambitious undertaking. Our focus today is on the Arctic, so let me turn my attention to the unique features that confront us in Arctic studies. The Arctic has long been a focus of international interest. Science and the unending quest to push back the boundaries of the unknown have always tied together those who explore and inhabit Arctic regions. As early as 1881, as shown on this map, there were 12 Arctic research stations around the pole. While primitive, viewed by today's standards, research conducted here was by no means without significance. The first instrumented data was collected from the Arctic at about this time, providing critical continuity with today's data. The sometimes brutal natural challenges and logistical obstacles to living in the Arctic and conducting research there will always prevail. These difficult conditions have long forged bonds between individuals who share the Arctic experience and have established the basis for mutual cooperation and concern among the Arctic nations. A view from the top of the world indicates what close neighbors the Arctic nations really are. And like all neighbors of the world over, we have common interests. Among them is evidence that the Arctic is experiencing greater environmental change than any region in the world. The scope and scale of these changes are unprecedented in recorded history. Moreover, the complex and dynamic Arctic system has demonstrated the capacity for rapid, amplified, and unpredictable change, with both local and global implications. Understanding these challenges is vital to inform decisions that will shape our response as a global community. And new knowledge, together with new technology it spawns, is a prerequisite for crafting those solutions intelligently. We do not yet fully understand the changes occurring in the Arctic. Now is the time to change this. New tools are available to make the needed observations and synthesis. They range from satellites to ships to sensors, and from genomics to nanotechnology, information technology, and advances in remote and robotic technologies. The litany of Arctic environmental change will be familiar to all of you. On land, permafrost is melting in some areas, raising questions about possible impacts on seasonal lakes and the wildlife and humans that depend upon them. Glaciers in the Arctic are retreating and thinning, a phenomenon that is not confined to the Arctic, but is global in scope. The melting of the Greenland ice sheet raises concerns about rising sea level. There's enough frozen water in Greenland to raise global sea level 7 meters. Sea ice cover in the Arctic is decreasing in extent, a visible indicator of warming. We don't yet understand the complex and multiple feedback mechanisms involved that may influence future climate. And as the ice sheet melts, along with other northern glaciers and sea ice, fresher and less dense water flows into the North Atlantic Ocean, creating seawater of lower density. This less dense water may weaken ocean circulation. Arctic ecosystems show changes, including earlier bloom times for some Arctic flora and variability in migration for fauna. Humans have been an integral part of the Arctic polar environment for the last 10,000 or more years. Indigenous peoples, as well as other Arctic residents, have influenced and been influenced by the natural environment. Little is known about the role that environmental extremes play in shaping individual and social behavior. The people of the Arctic are contributing their own valuable observations on change in the region, and these transformations directly affect their everyday lives. By some estimates, around 70% of Arctic indigenous languages are now endangered. Arctic language, culture, and environment create a seamless tapestry, and to lose any thread is to risk losing the whole. Efforts are needed to understand and preserve this rich and valuable heritage. This comparison of voice and data transmissions in the Arctic should dispel any lingering belief that the rapid spread of new technologies and the phenomenon of globalization have yet to touch Arctic regions. We need to understand how these profound technological transformations might affect those living in the region. Social and economic change is not a discrete phenomenon, but is woven into the fabric of the complex and dynamic physical and biological systems in the Arctic. Such change, whether environmental, biological, or social, has implications for the rest of the globe. Arctic change ripples across the planet on a spectrum of timescales, through the atmosphere, oceans, and living systems. We now know that the Arctic influences dramatically what happens everywhere else on the planet. Many of today's greatest challenges are inherently global. In the Arctic, this challenge is magnified because Arctic systems are intimately enmeshed with the vast biogeochemical cycles that sustain life on the planet, most particularly with climate cycles. It is not only possible to make progress, it is urgent that we do so. Nobel Prize-winning Paul Crutzen has coined the phrase Anthropocene age to describe the present day as the first geological era in which human actions have resulted in impacts on our environment that are planetary in scale. In today's climate of high-velocity change and rising expectations, we need to acknowledge the constraints that sustainability puts on our actions. For these reasons, climate change research and environmental observations in the Arctic will be a major focus for NSF-IPY activities. We are only beginning to understand the full extent of the impacts that climate change may have on the environment, and even less is known about effects on human health, the spread of infectious diseases, and the economy. We have the knowledge and tools to advance our understanding, and we recognize the urgency of the task. Another ingredient is necessary to move forward. We will need to strengthen, deepen, and expand international collaboration in order to meet the extraordinary challenges that confront us in the Arctic and across the planet. Discovery is no longer the purview of one scientist, one institution, or one nation. It is increasingly the result of connections that crisscross the globe. The very conduct of science and engineering has changed as boundaries between disciplines blur, and increasingly novel discoveries occur in the unexplored territory where different fields of science and engineering converge. Thanks to our enhanced communications technologies, the science and engineering community is now global in scope. We are almost now a world without boundaries. An important case in point is the planned Pan-Arctic Observing Network, or AON, an effort to significantly advance our observational capability in the Arctic. As a means to address the several questions of search, the study of environmental Arctic change, AON will help us document the state of the present climate system and the nature and extent of climate changes occurring in the Arctic region. The result will create a long-term legacy for future generation of scientists and policymakers. NSF, together with the National Oceanic and Atmospheric Administration, is developing atmospheric, land, and ocean-based environmental monitoring capabilities that will be key components of the planned network. AON will include a network of human observations and indigenous knowledge in the Arctic. In approaching this enormous task, we will need to draw on every available resource. Satellite data from NASA, for example, have greatly informed our understanding of climate change, most notably by documenting changes in the Greenland ice system. NASA is working closely with space agencies around the world in order to bring the enormous capability of their combined assets to bear on IPY climate change research. A circumpolar observation network will also require collaboration among all Arctic nations and the participation of those living in the Arctic region. The task is simply too large for any one nation to undertake. Important observational data are required from many sites around the pole. Change is taking place across the region, and it is essential that we measure and analyze change on a correspondingly fine geographical scale. New data will help refine the output from computer climate models, giving us more accurate predictions of change on a regional basis. This information is especially critical to Arctic communities. There are many other pressing issues on the Arctic research agenda that require international collaboration. One important objective is to increase our understanding of the place of humans in the Arctic system. Humans and polar communities have adapted to life in the polar environment, which for most of the year is both cold and dark. What factors contribute to vulnerability, resilience, and sustainability of human cultures in the Arctic is an important question of deep interest, not only to researchers, but especially to those who reside in the Arctic. Also important are a host of questions about human and social dynamics. One example is how settlement patterns in polar regions affect education and the development of human capacities. Of course, the need for fundamental understanding extends to all Arctic life, from humans to microorganisms. Another critical area of research is the investigation of ocean circulation in the Arctic and North Atlantic. I could name many more, and the list of Arctic research needs is long. Progress will depend critically on how we work together. Our ability to work on global scales is in large measure a result of revolutionary advances in computer, information, and communications technologies. In time, a comprehensive cyber infrastructure will connect the international community seamlessly And we need to improve substantially the complement of cyber infrastructure in the Arctic, particularly as we move forward with an Arctic observation network. Arctic teamwork begun through research and education can lead to broader cooperation among nations in policies for the oceans, the environment, and the full scope of human influences on the planet. International collaboration at its best generates new, often unforeseen opportunities for further partnerships. It is also an important way to quicken the pace of research when results are urgently needed. I have yet to mention education. International Polar Year activities present an extraordinary opportunity to educate young people and the public about science and technology and its significance for the future of the planet. The monumental changes and extremes of the Arctic, its mystery and diversity, its many cultures, its unique flora and fauna, all of these features can fire the imagination and engage our youngsters in the excitement of discovery and exploration. It is no longer adequate to simply inform young minds. We now have the ability and the responsibility to engage children in the discovery process, in the classroom, in the field, at museums and aquaria, and in the home. And as science and technology take on ever greater significance in our lives, it is increasingly important to have an educated public that appreciates the role that discovery plays in ensuring a sustainable, healthy, and prosperous world. Science and technology have always been a powerful force for human progress. Today, more than ever before in history, we have the knowledge and technology to unravel the staggering complexities that pervade the Arctic system. Much of the leadership required to make progress on all these fronts is here in this room. Each of us and each of our institutions, organizations, and nations have a critical role to play in IPY and beyond. 50 years ago, the International Geophysical Year established the notion of scientific diplomacy, the idea that scientists and engineers working in international partnership could solve problems of mutual concern and could further the interests of peace and cooperation among nations. That was also a time of heroic exploration, when Dr. Vivian Fuchs and Sir Edmund Hillary successfully completed their Trans-Antarctica expedition, a feat which had long remained a dream after Shackleton's disastrous attempt. Today, we have crossed the threshold into a new era of exploration, an era of discovery very different than that of Fuchs and Hillary. The explorers of the 21st century are opening up new conceptual frontiers in science and technology. Another half century into the future, a new generation will judge the diligence and wisdom with which we pursue our opportunities for progress and meet our opportunities and challenges. At NSF, we look forward to being part of the winning team with our colleagues and friends around the globe. It is my very strong belief that 50 years on, the next generation of Arctic explorers will be able to look back on a full century of cooperation, friendship, and scientific progress. Our deliberations today, and more importantly, our actions tomorrow, will be a vital part of that legacy. Thank you.
As a former career diplomat, I could not agree more with your message and your words. Thank you very, very much, Dr. Bement. Now it's my pleasure to turn the program over to Professor Jackie Grebmeier of the University of Tennessee, and also a U.S. delegate to the IASC, who will conduct the first panel today. Jackie, welcome.
Thank you very much. I need to. Thank you. Get out of here. Oh, no, I don't want to do anything to this talk. There. It's down here in the science panel. Thank you very much for the invitation to moderate the International Science Panel and to bring forward some of the concepts of the networking and the planning that's been going on to bring together synergistic developments for science in the Arctic. So I think first off, I would like to bring, once I bring this forward, the science panel, not Savi, right here. Okay, thank you. Go ahead and I'd like to go ahead and invite the panel to come up and join me in the front here. Actually, maybe what I should do is introduce you to my 4 slides to kind of get the broad picture, and then invite the 6 people up to the front of the podium. So the goal of the goal of the International Science Partnership is to bring forward in our discussions how science planning organizations have been addressing some of the vision of facilitating international research and educational activities, not only during IPY, but beyond, as a post-IPY legacy, actually, of this networking. So what we've decided to do is to bring together various international planning and management and policy leaders to address some of the achievements that have been done on international planning, gaps, challenges for doing this, and some of the lessons learned. And what the format is going to be, I'm just going to take a few minutes to bring up some of the larger IPCC type of concepts that will be brought forward through the rest of the day, and then invite the participants to come up. And the panelists, as you can see, are made up of Carl Erb, from the Director of OPP at the National Science Foundation, Savi Navayana from the Canadian Department of Fisheries and Ocean Science, Sergei Priemikov from the Arctic and Antarctic Research Institute in St. Petersburg, Russia, Hanna Petersen, Director of the Danish Polar Center, Jingping Zhao, who is from the Research University of China, from the Ocean University of China, will be giving a presentation on behalf of Dr. Zhanghai Zheng from the Polar Institute from the Polar Research Institute of China in Shanghai, who could not be able to attend. So at this point, just a few points that I wanted to bring up. We know that the IPCC came up with their release in February of 2007 of some major findings related to climate warming in the Arctic. And just to outline some of these, the global mean temperature rise, the global average sea level, and these will be part of the discussions that we talk about today, and the changes that are going on in the snow cover, decline in the snow cover. The Arctic versus global warming and the annual temperature anomalies, both of them increasing with a doubling in the Arctic regions. And that what you're seeing is a comparison between the earlier, the 19th and 20th century, and the rise, particularly in the recent decades. Other topics, further changes are in the Arctic related to the Arctic sea ice. It spans the permafrost issues. These will all be part of the science talks. And the change in the maximum ice cover, or rather the decrease in that maximum ice cover in the Arctic Ocean. And the projections for future changes. These will be greatest on the land areas and in the north, and least projected over the Southern Ocean and parts of the North Atlantic. So this is just a preliminary. There was a lot of information that came out on the physical driving forces from that report. And at this point, I would like to invite the panel to come forward and to begin their presentations and the discussions. No, the first, Carl, you can sit anywhere you would like. Just take your seat. It doesn't. It's going to be Carl, Savi, Sergei, Anna, and
So the first speaker I'd like to introduce will be Carl Erb from the Office of Polar Program at NSF.
Thank you, Jackie. I think my director's already given my talk, so this can be. But I have some details. Maybe I can help fill in some information on what we're doing. I might say with a very, very strong support of the director of the agency, the deputy director of the agency. I'm in a very enviable position trying to execute a program that my management so strongly supports. I'm going to work from up here because then I can see the screen. Can you hear me? Am I close enough to the mic? Thanks. So, I went too fast. The vision that you heard the director describe just a few minutes ago has been derived from a variety of sources. He mentioned the ICSU planning documents. He also mentioned the Academy's vision document that Mary Albert shared the preparation of. They're also derived from two very seminal IASC documents, documents prepared under IASC, the ACIA assessment, which pointed out very clearly that change in the Arctic not only was taking place on a regional basis. That the change wasn't uniform across the Arctic, and that presented a very important challenge for future research. And then most recently, the ICARP-2 study, and I'm going to focus particularly on Chapter 9, I think it was, of that report, the climate change section of the ICARP report, that really sets, I think, as well as I've seen, probably better than I've seen anywhere else, a research agenda that can help us understand what is going on in the Arctic and what will go on in the Arctic. So the primary focus areas that the agency has decided to work on, and when I say the agency, I mean the entire National Science Foundation, not just the Office of Polar Programs, but we're going to spend $60 million, we're going to invest, I should say, $60 million this year and a like amount next year. We, in this case being my office, Polar Programs, but also the Geosciences Directorate, very importantly, the Social, Behavioral, and Economics Directorate, the Biology Directorate. These are all parts of the agency that will be studying aspects of the program that Dr. Bement already outlined for you. The International Office is very prominently involved, the Office of International Science and Engineering at NSF. And they're going to help us provide funding for the glue that can bring different parts of the community from around the world together to address some of these issues. We've decided to focus on, for IPY, particularly the items listed here, climate change research, and I'm going to come back to the first element there, Arctic Observing Network, in just a few minutes because that's going to be the main thrust of my remarks. But I'd like to mention briefly that a second major thrust under climate change is ice sheet dynamics and stability, trying to bring about an understanding of what is happening and is, more importantly, what's likely to happen with the world's great ice sheets in Greenland and in Antarctica. And that activity already has developed a very strong international set of partnerships, some of them space-based, as the director mentioned earlier. For example, at a meeting that a number of us were invited to Ottawa last March. We discussed SAR capabilities for observing, and out of that meeting came an agreement by Canada to continue operating RADARSAT-2 with NASA support, with support from NOAA, NSF, and others through IPY. So there's one example already of a way in which governments have been working together to facilitate providing the data that the science community will need in order to understand future change. In Antarctica, there's a very broad partnership involving Germany, New Zealand, the UK, the US, other countries. China, very notably, part of that. Human and biotic systems, I won't have time to talk about very much, but the thrust there is again based on, in large measure, a study by the National Academy of Sciences that identified frontiers in polar biology, using the modern tools of genomics, proteomics, and so on, to understand at a genetic level, protein synthesis level, how microorganisms adapt and manage to function, metabolize, and so on at temperatures well below zero when there's no sunlight. And the human systems thrust is being led partly by OPP and partly by our Directorate for Social Behavioral Economic Sciences. Director Bement already mentioned some of the thrusts there, ranging from the ecology of infectious diseases to documenting endangered languages and many, many other areas. My job today is not to try to give a comprehensive overview, but basically generate some topics for discussion. So I won't take too much longer laying this out, but I can't avoid mentioning education and research. We've already had what I think are some spectacular successes on an international basis with teacher exchanges or teachers from one country interacting with classrooms from another country. And that's something we can build on. It's just very, very exciting to see fourth graders in different countries teaching each other about things like how can it be dark most of the time in Fairbanks when it's light most of the time at the South Pole, and trying to figure that out for themselves at the fourth grade level. There was a school in Anchorage interacting with another school. And I also would be remiss if I didn't mention that IPY, even though it's 2 years long, is only going to be the beginning, that this effort, it's clear now, I think, to all of us, that this effort is going to continue for several years beyond IPY, at least for 5 years. And so we have to start thinking seriously about the follow-up to what happens in 2009, 2010, and so on. So let me come back to the main point I wanted to raise for discussion, and that is the Arctic Observing Network. I've already mentioned the seminal studies that have influenced our thinking, all of which point out that, I forgot the exact expression the director used, but something about a fine-grained monitoring, not just monitoring, but observing of key variables in the Arctic that, as the ICARP study said, can provide an initialization for the climate model calculations, and I'm sure that we'll hear more about that this afternoon when John Walsh gives his remarks. IPCC emphasized, the IPCC report, the summary report, talked a lot about average changes, mean changes, as we saw in Jackie's discussion, but it also pointed out this issue of local forcings, how do local forcings interact with external forcings to produce these variations around the Arctic that so influence the living conditions, as well as the mean behavior of the climate system. So that is our major thrust in climate research, ice sheet dynamics, and trying to work with other countries to establish an observing network. Now, this is a map drawn from proposals to the U.S. search program and to Damocles. Both of these now are funded. These are proposal documents, so they're incomplete. And in particular, the search document only shows ocean systems, but there are also very important land-based systems. And I can mention, for example, Tixi in Russia, Ny-Ålesund in Norway, Summit in Greenland, Barrow in Alaska, Alert and Eureka, and so on. All of these have to be knitted together to make search a success. And the search program and the Damocles program has to be knitted together. And there's been really quite extraordinary progress on the part of the science communities, the EU partnership for Damocles and the US partnership for search, to begin that process. And it's largely been done, I think it's fair to say, on a scientist-to-scientist basis, or a group of scientists to group of scientists basis, but with the active encouragement of government officials, and enabled by an organization that we've all agreed to put together called International Study of Arctic Change, or ISAC, with the Secretariat in Copenhagen. Now, my Canadian colleagues could show a similar map showing where their observation stations are going to be. There are many other players involved in this. There's the space-based system. I've already mentioned the RadarSat activity. My director mentioned how NASA is working to coordinate with the German Space Agency, Italian Space Agency, ESA, Japanese Space Agency, and others to provide a complementary satellite-based observation. All this has to be knitted together somehow if we're going to be successful in providing the kind of input that the climate modelers need and that the science community in general needs to improve our ability to understand what might happen in the future. So what are the challenges? I think this is just about my last slide. Well, I've already mentioned the need to integrate these systems somehow, to set goals for the observing system. I think everyone in this room would agree that the goals have to be driven by science. We may have different definitions about what science is, but I think we all understand that we can't just create a network willy-nilly. It has to be put together to establish certain goals, to meet certain goals. How do we manage the data? I know my colleagues are going to comment more on many of these subjects. How are we going to operate the long-term stations in a networked way? Each station will be operated, I presume, by the country that's supporting it, but it'll have to, its measurement scheme would have to be integrated into the overall plan, or should be. How will the funding agencies provide the funding for these? How will we oversee, on behalf of the people who pay the taxes, the use of those fundings? And the subject I put last, because I think it deserves a lot of discussion this week, is the committees meet, is what are the roles of the different organizations that have very strong interest in this activity? How can they, what are the roles of these organizations? How can they make this observing network a success with support from the federal agencies? As a model, not really a model, but it would be nice in a year to be able to show a map of the Arctic that looks sort of like this map of Antarctica. This is a map of a program called ITASE. It's created in large measure by the science community itself, in which traverses all across that continent by different countries have been working together to develop an understanding of Antarctic climate roughly since the Industrial Revolution, starting from before the time there was extensive carbon emission into the atmosphere and continuing through. And the flags are there just to show the extent of this international collaboration. That's what's going to happen in the Arctic AON as well. But I think symbolically, at least, this is an interesting thing to keep in the back of our minds as we plan for AON. So with that, I thank you and turn over to our next speaker.
Thank you, Carl. So what I'd like to do, we'll continue on with the speakers and then have questions after that. Bobby? Okay. And you, this is the laser right there, and that's forward. Okay, that's forward, yes.
Thank you, Jackie. I'd like to start by saying how wonderful it is that the scientific community and the governments were able to come together in such a short time to implement the IPY. All of us had very successful IPY launch events on March 1st, and many of us have already planned a series of workshops, conferences, and educational and communication programs for the upcoming months. The hard work of many, many individuals around the globe has paid off, and we are now fully in the IPY. I would like to take this opportunity to recognize the outstanding contributions of so many individuals around the world and express my deepest appreciation to them. The IPY program stands out among the past and present ones in many ways, but in one aspect, it's quite remarkable. I think perhaps for the first time, I may be wrong on this, but it's my impression, a scientific program has caught the interest of local communities at large, and they have become active partners in its design and implementation. In addition, the focus of IPY is not just science. It has a strong human dimension element, which includes topics such as human health. As some of you know, in Canada, the theme of the science program is science and research focused on science for climate change impacts and adaptation and health and well-being of northern communities. Just to give an example on where the communities are distributed in the Canadian Arctic, of the 56 Arctic communities, I didn't count them. Marty Bergman gave me this slide, so assume that he has counted it. Of the 56 Arctic communities associated with the marine ecosystems in the next decade, over 90% of them will have some sort of community-based program because of land claims and co-management arrangements, cost-effective means of data gathering, spatial temporal coverage, allows incorporation of traditional knowledge with science, And there will be different models for different programs, ranging from locals hired for short period to assist logistics and for data collection for field programs, and full integration of the community-based management with working groups, priority setting for research, planning, and conducting fieldwork. Examples of community-based sampling in Canada include such activities as the marine mammal and fish harvest sampling, sea ice and snow, etc. The Canadian IPY program is built on this idea and has several projects that are closely linked to northern communities and health programs. I will list a few. University of Manitoba's the Viral Hepatitis Northern Network, a platform for addressing viral hepatitis in the Canadian North. University of Toronto's Dynamic Inuit Social Strategies in Changing Environment, a long-term perspective. McGill University's Inuit Health Survey, Inuit Health in Transition and Resiliency. McAfee Corporation's Engaging Communities in the Monitoring of Zoonosis, Country Food Safety and Wildlife Health, University of Northern British Columbia's Arctic Resiliency and Diversity Communities Response to Change, Museums Inuit History, Climate Change and Historical Collections in Arctic Canada, 1000 to 1900, and Champagne and Ishik First Nations, the Kwade Dong, Shinshi Discovery, expanding our understanding through linked scientific and community studies project, for example. As expected, the number of projects and the corresponding funding requests in almost all countries far exceeded the available funds. Consequently, each country had to struggle to prioritize and to balance its national priorities and international commitments. The net result is that in spite of the best efforts of dedicated scientists and governments, the IPI program has some gaps in terms of geographical and temporal coverage, gaps in the variables measured and science addressed. Agreed that we do not have a perfect program. Furthermore, implementing IPY has many challenges: the lateness of the funding decisions, ship time availability, projects designed in partnership running into difficulties because not all partners got funding from their countries, etc. But in spite of all this, we do have an Arctic program, and quite a good one. Furthermore, it's a real global program. Even countries which are not polar countries are contributing to it, and that's a very important point. As an example, here is a slide of the Canadian oceanographic observations highlighting the partnership that are already developed. Partners here include Canadian federal departments and networks such as the Arctic Net, partners with USA, NSF, NOAA, and universities, and with Japan, UK, France, Germany, Denmark, and international organizations such as WMO, IOC, AOSB, and its various subgroups. We all know that an important legacy of IPY should be a sustained observational program, and Carl touched on this. Designing and implementing a realizable, realistic, and relevant observational program would require considerable effort, and we need to work together to do that. This would also require maintaining the current partnerships, in fact, formalizing it somewhat, as well as fostering new ones. Canadian experience has shown that many sustained monitoring in the Arctic would need active involvement of the communities in the Arctic. We would also need to have agreements with shipping industry and the navies to support the program, because I think it is a very costly venture, and we need to make use of every vessel that is going to the Arctic as platform. This includes the commercial vessels, scientific vessels, and Navy vessels, including submarines. The observational program must be built on existing infrastructure. There's no point in duplicating what is already there. Let's build on it. And this infrastructure of WMO, IOC, and its subcommissions, and other intergovernmental organizations. A program of this type will provide ample opportunity for education and training for the northern communities and for the next generation, for the students in high school, universities, and Carl touched on that. And this is very important because we will be designing something, but who will be implementing it and continuing it? That will be the next generation. And we want to make sure they are fully aware of the importance of having the observational network in the Arctic, and at the same time taking into account the sensitivities of the people there, the environment, the ecosystem, etc. It's a real education requirement here. It is expected that some of the technologies developed and tested as part of IPY may be ready to use in an operational mode. The Arctic Observational Program should support such operationalization. This is where the R&D, and especially in the technology field, comes into play. We all know data management is a real challenge. We talk about data management a lot, but when we actually making it available on a timely manner, we have a long way to go. And this IPY and its legacy and its subsequent programs should focus on that, because the group which controls data and information really control the whole. So it's important the scientific community should have access to it, and then we will learn much more from the program. We should give a very high priority, both during IPY and post-IPY. And I believe once we had a basic monitoring program, there will be enough interest among the scientific community to use the information and stimulate research which needs to be supported by the granting agencies. Well, fundamental to making this happen is strong governance and the right governance. I don't mean top heavy, thou shalt not do this or thou shalt do this, but it is, the governance is supposed to facilitate whatever has been planned. And we have many examples of collaboration among supposedly large bureaucracies, such as WMO and IOC, and we should make use of that. And GOOS is such an example with UNEP, IOC, and WMO, and the previous director of the GOOS project office is in the audience here, Colin Summerhays, and Drifting Buoy program. Argo is another example of good governance making something happen. We will be discussing this topic this week at various committee meetings, and hopefully we will walk away with some kind of an understanding or action item for us to take to our governments. A few ideas. How do we set up a coordination body? I think that we need to have a scientific steering body. Maybe we will have there is already something existing, or we may want to build a new one. We may want to adapt it, but it's ideas for discussion. Scientific steering group with mixed government, academic, and local community. I forgot to mention that this was late last night. Membership. I think we need some formalization. So we need to have some kind of a memorandum of understanding with existing bodies for coordination of the observations and data management. There are a number of countries represented here, and we have the cream of the crop. We have all the necessary elements at this meeting. So I think we should be able to come up with a consensus to develop perhaps a scientific steering group, develop some terms of reference for the group, and some guiding principle for the MOU. We won't finalize it, but at least we should have a straw man put together. And I think in about 6 months, we need to come back with some national contributions to an Arctic observing network, because I think we have been talking about it for a number of years, and it's time we sort of this is what my country will contribute to an Arctic network. It's sort of what we did for GOOS or for Global Sea Level Program or something. We might be able to do that. So that's my hope, and I will stop there. I think that's my last slide. Thank you.
Thank you very much, Sabi. Sergey? Which one are you?
It's a COP panel.
Okay. Yeah. Thank you. Sergey Priamko.
So, I'd like to put your attention for the more practical questions. Is the first month of IPY and where we are now. It's a map show the ship activities during the IPY, and we will recognize immediately that we have a number of ships. It's 12 ships here, but in reality 20 ships has the potential to carry out research in the Arctic Ocean in 2007. Therefore, and we will recognize immediately that we have no choice. We should cooperate immediately. Otherwise, we will lose efficiency. Efficiency in terms of logistics, because ship logistics is
I need you closer
very
to the mic.
expensive. And we also will lose a lot in terms of science. Because if we will not develop the common strategy, we will not unify the regions of work, we will not unify our tools. We'll spend money, maybe not so efficient, I'd like maybe tell sometimes for nothing. Therefore, it's very important to develop our cooperation already. We need to do it immediately. And I also would like to show you another map. Because it's
Right here. Just click the top button here.
yeah. Now we'll put your attention to the terrestrial part. In Savi mostly involve you in what's happening in the Canadian, and I'll try to involve you into what's happening in the Eurasian Arctic. So you can see on this map, it's a number of the IPY projects for each sub-region of the Eurasian Arctic. And you can see that a pretty big number of the projects will be carried out more or less simultaneously in the same location. And therefore, it's very good reason try to cooperate each other, unify programs, unify logistics, and this brings us real cooperation. Therefore, it means to me that first of all, it's very important for all our community to be well informed about the intentions of each organization, each participant, each project. It could be represented by the different number of people. And the second, what we need, I guess, is like a second stage of cooperation, and based on information, try to coordinate efforts. So, and the third one is the top level, it's real integration. And in this moment, we have different examples. For example, such a project as a Scherr or Damocles, which already is a very good example of a very good integration. And if we'll come to the ship activities, we also made some efforts and try to coordinate the most important, most pronounced expeditions. And in Russia, we had a meeting and tried to cooperate ship activities of academic Fedorov. It's a Russian ship which can carry out more than 100 participants. Then the Polar Stern, you know, everybody knows Polar Stern. Then it will be another icebreaker which will carry out, on board which will be carried out the joint US-Russian research, well-known program Neighbors. And we agree that when we will clarify our plans, we will try to a little bit change our sections and agree not repeat each other, always repeat exactly in the same locations to collect much more information. And another example of the, I guess, very special development of the cooperation recently, when the several countries have recognized that the cooperation really, we really need to cooperate. The several organizations from different countries have established the special IPY sub-office. It's Arctic and Antarctic Research Institute, Arctic Wegener Institute, European Swans Foundation, Norwegian Polar Institute, OPP, NSF, and Swedish Research Polar Secretariat. decided to establish office, which the main aim of which exactly to provide people with extended information. It's to help each researcher to find each other and to learn more about activities, and just to provide or to supply people with a goodwill and intention to cooperate each other. And on the bottom, you can see the website of this sub-office, where we can find much more information about all IPY activities related to the Eurasian Arctic. Thank you.
Thank you.
I'd like to introduce Hanna Peterson. Would you like to? And this is the, that's a laser, that's forward, and you need to speak in the mic, this is being recorded.
Okay.
Yeah, that's forward.
Okay, thank you.
You're welcome.
Yes, thank you for inviting me to Bement this panel. And I will like to start with this picture because I think it's very well show how big interest there is in Greenland. I can refer to the picture from the Antarctic, so you can see as this picture also shows that 350 researchers and from 51 countries participating in 138 IPY consortia are interested in making research in Greenland. And I think this was an overwhelming interest, and I start with this because it also tells a little about how it influenced the thinking in Denmark. I think what we thought we had to do was to facilitate all these people coming to Greenland. So we have decided to establish an IPY office in Kangerlussuaq. And Kangerlussuaq is, as many of you maybe know, the interest to West Greenland. So everybody that have to start will show up in Kangerlussuaq. So there will be provided facilities to helping and informing and advice, and hopefully also enhance the cooperation. Then also we have decided to keep the Sagenberg field station open. Normally it's only a summer station, but now it has been decided to have a whole year observation, and that's also because it has been driven of interest from science that people wanted us to open this for a full season so they could get the observations from this place. I think I will mention Sagenberg because talking about observation network, this is a very special station because now for 10 years there had been made monitoring for many different disciplines, marine, terrestrial, and biodiversity. So it is a long-term running program. And in fact, when it started, it was not that usual, but it has come up now that it will be a very important series of data that will be established at the Sagenberg station. And then what we also did to help was there was been making a web portal showing all the places where all these projects will take place. And as you see, it's all over. And as an example, I can show that the summit at Greenland, if you point of this, you will get information. And I have taken Summit because this is a station driven by the National Science Foundation of the top of the ice cap. It's a place where there's already international cooperation is taking place, but I think there is much more possibilities in this station, and there have also been taken steps to have a negotiation between National Science Foundation and the European Polar Board to try to enhance the cooperation about the station. So that may be something that would be followed up in the International Polar Year. I also want to mention another example of partnerships because the International Partnership in Ice Core Science, the IPEX, they have planned to make a deep drilling at Greenland in the polar year. And they do it under the Greenland Ice Sheet Stability History and Evaluation Program. And I can't resist to cite their own argument for doing this, because they say the size of the logistic, technological, and scientific effort required has led to the realization that ice coring affects need to a multi-institute and often multinational, from the three-nation tree drilling to the 10-nation effort in EPICA. So that is saying very directly why it is important to have more partnerships in the Arctic than in many other places. I was thinking, we were also asking about what kind of problem we have faced, and I can't resist to take funding, even if I'm not complaining about the amount of money, because I think that's a problem for everybody. But I think the timing is really a problem, and especially in the polar areas where the windows are so small and then narrow. So the challenge to get all the program established, get contacts, and also if they really are dependent on each other, then get all the funding done in the same time. That is really a challenge. And I think Denmark has faced it. We just got the money very late. And of course, it's better than nothing, but it's just set in relief that it is difficult to get everything to go smooth and fast. And I do not know if this audience have some ideas how this funding could go more smooth. At least there have been some increase in cooperation, because the European EC, they have established a European Polar Consortium, and some of the idea is to talk more about funding possibilities among the European countries, so that maybe will help a little bit. Then I also will say about the awareness, because in Denmark it's quite clear that all these many nations showing interest for Greenland have made some thinking around. And one thing that's happened is that now there will be made a general Arctic strategy for the kingdom, because that's not been the case, that there's been such one before. And I do not really what it will end up with, but it's quite clear that the starting is something coming up by the IPY thinking that we must do something. Then I also think more and more people are seeing that there's very, very big possibilities for Greenland because it has this unique location in relation to core questions for climate change. I can just mention the ice cap and the ocean deep water formation, and also studies of societies in Greenland that have been changed during the centuries. So I just want to say this because the IP already have influence in the way people are thinking back home. So I won't say very much about observational network. I think we will discuss it later here, and something has been said. But the only thing is I can say it has been said for 15 years or more, and it seems like everybody agree, everybody want it, but it must be difficult because it's never really set up. So thank you. All right. Yeah.
I would like to invite Jinping Zhao is standing in for Zhanghai Zheng out of the Polar Research Institute of China, and his flights and bus were delayed, so he's going to give a brief description of the IPY plans China.
Okay, I'm Jinping Zhao. I didn't prepare the PPT because the talk should be given by Dr. Zhanghai Zhang. She's coming later by the visa program. So I will give a brief introduction about China's plan for the partnership panel. You know, China is not an Arctic country, so the central government pay more and more attention about the Arctic study because China is experiencing a serious problem in China's social events. So in recent years in China, there's a lot of police experience the drought for more than 400 cities, lack of water. And in my province, in the spring, drought is very serious. So each family can get one bottle of water the water is transported from very far place by the army. So the people don't drink the water, only feed the water to the cow because they need the cow to work on the field. So people only eat watermelon for 1 month each year. So it's very serious. And in another part of China, it's flood in summertime is very serious. And we meet a lot of loss. So in this year, things become more serious. In the spring, there is a strong surge attacked China and overturning the train, and a very serious wind in the Beijing area, and much warmer here. So people, meteorologists before, think about this phenomenon is correlated mainly about the El Nino or Asian monsoon, something like that. And recent years for the study in Arctic, more people believe it is correlated with the Arctic activities. But we find in China, we have only a small team for Arctic study. So we have no accumulation for Arctic research. So people just ask for more opportunities to collaborate with other Arctic country to do the study about Arctic. The good news is the central government can provide more funding about Arctic study. It's partly because China become richer, and another is become more tax from the government, receive the more tax. So people, it's good news for Arctic study. So I think we can do in the IPY and the post-IPY, we can do something about that. Firstly, we have an icebreaker. We are prepared to come to Arctic Ocean every 2 years for the Arctic cruise. And much more, we can provide some equipment and instruments to develop some instruments for Arctic study, especially. The main scientific issues we concentrate is about the ocean circulation in the Arctic Ocean and the Greenland Sea, and for the upper ocean thermal processes for during the ice cover retreat. So we can do some thermal balance and optical observations about the upper ocean and the interaction with the atmosphere. So we plan to deploy moorings in the Arctic Ocean in the continental shelf about the observation for the ocean circulation there. So in past 5 or 10 years, China prepared a long-term priority plan for the study. We list the Arctic inside that. So we just want to organize a better team, better and bigger team to do the Arctic study. So we sincerely search some collaboration with the Arctic countries and get your help and develop some our own solve our scientific issues. Thank you.
Thank you, Jinping. And now I'd like to invite Anders Kalquist to come up, and he's going to use the traditional blackboard to do his presentation. We'll use this one. How novel.
It's a radical approach to lecturing, but okay, I have the privilege to be the last one in this group, and I think one of my tasks would be to try to lead into the discussion that will follow from these presentations. We have had quite a number of interesting examples of science partnership which have been achieved, which should have been achieved, and maybe mostly also which we hope to build on and hope to achieve in the future, especially now for the IPY. But I like to reflect upon this theme in more general terms, not so much talking about our specific Swedish activities at the moment, but as I said, more trying to lead into a general discussion. And I think the bottom line of what we'd like to discuss is what are the key elements of successful science partnerships? And of course, it follows from that, what can we learn from what has been achieved? And I think basically we are not only learning from success stories, but we should probably spend much more time thinking about the failures that all of us probably have some experience of in this area. And what are the elements for success? What are the necessary and sufficient conditions to make this happen? I think, first of all, and that has been clear by the presentations we have seen, that there is no single model for science partnership. We need to look at the very broad spectrum of situations that we can refer to. And we are talking about processes which are basically science-driven. But science itself and science planning is only part of the story. To get things done needs much more than a science plan. And as you can see, also heard from the previous speakers, there are matters of, as Hanne mentioned very clearly, matter of timing. There are obviously a matter of resources. And there are obviously a matter of organization and decision-making structures. And I would like, just for our discussion now, to suggest a couple of structural elements of science partnerships, which I believe makes a difference, and put our various examples now into context. So that's now when I'm trying to start doing something on this board. I think one element which is important really is the number of partners. We can go from a situation where we have basically started with bilateral agreements in this end and come over to multi-national activities, where we basically end up in organizations, international structures, which has a character organization. So that is one dimension which I think is very important for judging partnership. The other one, which I think is equally important, is the kind of a timeline going from what I would say missions, specific activities with a very real-time perspective of starting and ending, and then something which we could call long-term.
Excuse me, I don't like to interrupt you.
You will.
There you go. Thank you.
Any difference?
Oh, yes, because you're recorded now.
Oh, so this is for
The
history.
posterity.
That's for long term. Okay. And I like just, I'm sure this is so simple that you can all imagine what it's all about. But I like also to put a few examples in here, which I have some experience of. And let's start down here. The typical mission, which was orchestrated with a number of countries. This is the Arctic coring expedition in 2004, where we were drilling on the Lomonosov Ridge. So this is a typical sort of scientific partnership that would be in this corner. I'll take another one. There are many in this area, of course, but let's again take one that I know from Sweden's experience, which it came to be known as hot tracks, which was really a joint venture between the US and Sweden with two icebreakers, Healy and Arden, that made a journey across the Arctic basin from Alaska to Scandinavia with a geophysical oceanographic program on board. This is a typical bilateral mission-oriented science cooperation. To take something bilateral with a very long-term commitment, I would like to point out an example from Antarctica, which I think is a splendid example on science cooperation, namely the Concordia station, which is run by France and Italy together. And it has also a very interesting history, which I shall comment on a bit later. And to take something which is multinational, long-term, again from Antarctica, I'd like to mention something which is not really science itself, but it has their importance for science. That is a drumland cooperation between a number of nations in the drowning Queen Maud Land sector of Antarctica to actually establish a sustainable air link to the continent and within that part of the region. There are many other examples that you can put into wherever you like. Ice Cube is a good example, I think, where you could have a fairly long term, but something that would be in here. And you can think about your own examples. I like to mention one, which I think is also a success story in many respects, and that is the EPICA drilling. The EPICA drilling is a multinational oriented program with a clear mission. And there is an interesting connection to this long-lasting development of the Concordia base. Actually, the story goes, EPICA was looking for a drill site in that part of Antarctica. Dome C was chosen. The EPICA drilling needed an infrastructure, and the infrastructure was provided through a station that was in Concordia. The station itself led to quite a different scientific development, where now this is basically taken over by the astronomers and astrophysicists. But it's science driven in sort of two steps. So I'll leave this to you as just a way of visualizing what we're talking about, in at least one way of doing it. So let me now just finally mention what I think could be factors for successful scientific cooperation, as I have at least seen them through my experience. Well, there might be many, but common goal. This seems to be a trivial comment, but it is far from it. If you take ASEX again as one example, this has had a very specific goal, namely to take as a long sediment core as possible at one specific point. So this is really a focal point for a scientific cooperation, which I think is tremendously strong in driving the whole organization and everything. Mind you, though, that before you got to the point of actually getting a common goal, there was a long process of planning and selections and prioritization within the IODP program, which is really the carrier of the agreement. The second one I would like to mention is division of labor. In my experience, the easiest way of getting things done is when you have a clear understanding of who is doing what. And again, it's not a trivial thing. I mean, this could be seen in many ways. It could be seen, as Sergei pointed out, on a geographical scale. It could be seen in disciplines, and it could be seen in platforms. if I take this hot tracks example, this was a division of labor in the sense that we had two platforms, quite clearly, in the US and then Swedish, and we had a division of labor on board those. So Healy was doing a certain type of work, and Odin was doing another type of work, which were complementary. I think to be quite specific and clear about these factors helps a lot to actually get things going in terms of science cooperation. I've mentioned two which may be less fundamental, but I would say if we get in a kind of scientific cooperation where we can rely on exchange of services and real resources rather than starting to exchange money over the banks, it makes life much easier. And it's of course not always possible, but I know, especially for the Antarctic scene, that a lot of wheeling and dealing goes on this way. I do this, you do that. We don't need to actually write checks. And the fourth and last point, which sometimes is very helpful indeed, and that is the idea of a lead country. Some of the most successful things that have been pulled off have really been started by someone taking that, we are going to do this, and if you want to join us, you can. And that is, of course, Ice Cube is a prime example where, of course, this is a US-led program from the very start, and it's become very international over time. So starting with the lead country also is a great way of creating a momentum in science cooperation. So these were some reflections on what could be done or should be done or whatever.
All right. Thank you. At this point, I'd like to start the questions going with the panel and then open it up for discussions. And one of them is we've had presentations about some of the partnerships that have developed and some of the successful ones. And the question is, are there some key components? And I think, Anders, you started to put them down of success. Is there anybody on the panel that'd like to expand on those key components that are necessary for the successful partnerships that have developed or that need to happen for future development? Carl?
Well, I think this is implicit in what Anders said when he talked about goals, but first and foremost, there has to be a group of scientists who are willing to bet a significant part of their careers on making a project a success. Without that, I don't think none of us would be interested in supporting such an activity. So that's absolutely crucial.
All right, thank you. Anybody else want to add to that? Okay, then the next question are there are challenges that were had along the way to get to these successes, and as the AON or the Sustained Observing Network or combination is going forward, what do you see as challenges, and how can the facilitators at your level move that forward? The challenge.
Is this specifically for AOM?
Yeah, I think we can start with AON, yes. I mean, there must be challenges, otherwise it's taken a while to go. Hannah?
Yes, at least when I'm looking at this list and I'm thinking about the Arden or Scherr or whatever it is, then it seems like, I mean, I come from a country where we have these Lego things, the small bricks, and they can build upon each other, but they need a platform. And it seems like this thinking about the lead country, I think that's really been something that's been difficult. And it shouldn't be a lead country, but a lead thing, because there's so many people on the scene, and how to come to the conclusion who should be the leader. I think that will help a lot of getting forward in this question.
Savi?
I think for the Arctic Ocean Network, first we have to decide on an initial observing system and what should be the Cadillac model, and one brick at a time, start with an affordable, realistic initial observing system. I think the elements are there, but we need to come to an agreement on what that is, and we really need strong scientific input for that. And once you have that, then we can take it to our managers and whatnot and try to get long-term support. By definition, an observation system means sustained, long-term, when periodically reviewed and used by all scientific community and all interested groups. So we need to define what that is. That's one of the first task, I think, in my mind.
Okay. Anders and then Carl.
I think it's important to reflect on failures or things that we have not fully been able to achieve. And I think Sergei's picture is an interesting one, showing the icebreaker activities as it turns out to be, and ask yourself, why has this not been better coordinated? And I think this is a key question really to ask ourselves. And one of the obvious, maybe obvious, but still way of commenting on it is to say that, you know, the timing is such that people are making decisions in a way that it's suddenly just seeing the facts. And can we change that mode of operating somehow? I think it's too late for 2007. 2007 is done. What we are talking about is 2008 and the legacy of IPY after that.
Okay. Carl?
I think timing, one of my colleagues mentioned timing is an issue that we have to take into account. IPY is supposed to end in March of 2008, so that's 9. So
It's a 24-month year.
Sergey?
I'm not absolutely, I agree with you, but nevertheless, I believe tier coordination is still possible, because each ship can a little bit move ahead from the track if it brings much more science. For example, we have reviewed that the Polar Stern track, Academic Fedorov track, some like shallow water ship tracks are crossing each other. And it's very easy to decide that we will divide our activities, or we'll repeat our activities but through the same section. And bring us a lot of research activities, but it can be done on the operational level. And another problem, which I guess our problem originating from another problem, we have quite a lot of the Arctic research bodies. It's like ISB, FAR, but up to now we still have not body which can take responsibility of such coordination.
Carl?
The timing of funding becoming available for the various countries' projects has, I think, been a factor that's inhibited putting together the international AON. But we shouldn't view that as a failure at this point. It really just means that we have to work at it, and we have to recognize that to create a legacy is going to take more than the 2 years that's been formally allocated to IPY. So at least in my own mind, I'm beginning to think of the IPY period as the formative period during which we get things started, get things in place, and over time gradually integrate the whole system. So we now, Canada has made in a not too distant past, I think fairly recently, its decisions about funding, and now can begin to be part of the whole process of integration that's begun with Search and Damocles, through ISAC in the case of Search and Damocles at least. We've been talking with our Chinese colleagues in about 2008. Been talking Sweden, Norway, China, the US, at least, about pooling our resources to develop an Arctic Ocean capability to integrate an activity there. And it's embryonic. It'll depend, like everything else, on the science community pushing us to make that sort of coordinated activity a reality. And if it becomes a reality, it'll be a 2008 summer reality, maybe even later than that. And the results from that activity then would still feed into I would think, into an observing system, making key measurements, making them part of the benchmark data in the future. So we've got, because of timing, we're proceeding in some respects, with one column advancing rapidly, and then another column a little bit later on advancing rapidly and passing the first column, and so on. And we need an organization. I think the biggest challenge is we need an organization that will work full-time to keep communications going among the various partners, prospective partners, engage new partners, raise issues of data management that Savi talked about, data sharing. All these challenges have been accomplished and met successfully by the International Seismology Project, for example, shares data immediately. As soon as a seismometer picks up data, it's available to anybody who's part of that system. So all these problems have been solved before. It's just a matter of having some group of people working more or less full-time, I think, to move things forward.
All right, Hannah?
Yes, I am also wondering if we could use the opportunity that climate change, I know there have been concerns all the time, but it seems like it's still growing. And together with the IPY year, I think it's very, very clear that for many other than countries working or living in the Arctic, that this is something that is necessary. So I wonder if some organizations outside our normal Arctic family or Antarctic family could be interested. And I myself have the experience that the OECD Global Science Forum have seem to be interested in the IPY process. So I think, this is a kind of a sign that someone from outside maybe could be convinced that this is not only a case for Arctic country, but support is needed on a global level. So that's maybe something that could be done.
All right. At this point, I'd like to open up to the audience. I have some more questions, but I think you may well have some too that you would like to pose to the panel. Keep them on their toes. Hello?
Just to follow on, can you hear me if I talk loudly?
Yes.
Yeah. Just to follow on from what Carl and Hanne just said, this particular theme here is international partnerships and how do we move forward. And
Microphone? Excuse me. Don't want to interrupt.
no, I'll keep on trying to talk loud. And I'll just make the observation, if we look at the previous polar years and IGY, these were all top-down driven. We will never get back to that situation. So decisions were made actually quite early, and the scientific community, for what they were, they had a good idea what was happening. Today, in most of the countries involved in IPY, we don't have the top-down process any longer. China is one of the very few that announced 2-3 years ago what they was going to give of money in this. Most of the countries are getting their projects announced now. That's a reality I think we will have to face for all future. That's the way we are working. We are working bottom-up, we are working competitive. However, there are opportunities, I think, to use now what's happening in IPY to start thinking on specific issues, and that, I think, is the challenge for us now over the next year or two. When we're talking legacy, how do we put things together to make sure those things that need long-term activities actually get better coordinated? And I don't think it's negative that we have not been able to do that at the start of the IPY, because we are in a new world, and we're going to now have to change some of our thinking in how we do things. I'm not sure how we do it, but I'm quite sure that we will have the IPY experience to make us move forward if we want to put goodwill into this. And that, I think, is the challenge, whether it's ISAC we use for this or some other bodies. It's the challenge that those that sit with the power and are used to making the decision based on national priorities start to think in the Arctic, start to think how do we make it based on international priorities. It's a huge challenge, but I think it's a challenge and not a problem.
All right, thank you. Are there any response by the panel or to that? Okay, question, yes.
I'm just, I'm not sure if it goes both ways, but I agree very much with what Anders said, that you need leaders, but my experience in the global tropospheric chemistry community is that it's amazing how one or two or three individuals, not some sanctified board of government ministers or whatever, have been able to make huge programs, but it's very much someone from NASA or NOAA or from DLR says, we're going to do this and here's what we want, and all of a sudden there'll be a whole bunch of partners. I mean, certainly the ARC campaigns is blessed by IDAC and WMO, but the real leaders are a few individuals, like Fred Fahlenfeld and Stu Pankett. You know, and they've had tremendous coordinated activities. It's a little easier, I think, than what we're talking about here, though, because it is down on this short time scale that you're talking about. Maybe that makes these things easier. But, and I think the example, there's a poster outside from Andreas Stoll and Kathy Law, who have created out of nearly nothing a major international coordinated campaign called PolarCap. This is kind of the same thing. And right now there's probably 25 or 30 different components to PolarCap, which we ought to be linking more closely with the icebreakers, which I don't think they're very well connected to that community. But I just want to really agree with Anders, but I'm saying I don't know how we do it for the next 20 or 50 years or however long.
One more question. I think it's getting close to time. Go ahead.
More than a question is a general comment. I want to take up some of the things that Anders said in his presentation, which are very important, and that brings me to stress once again, the importance of looking for synergies with the Antarctic research. This is something that takes place at the level of countries, where many countries are active in both environments, and they tend to substitute the word Antarctic or Arctic with the word polar, because it is becoming increasingly important to research how important it is to carry out comparisons between, for example, ecosystems and things like that, looking at adaptation. Anders pointed out a common goal. I am a biochemist and I work in biological sciences, and I'm sure that many of the people that work on biological sciences here will agree with that. One of the common goals may well be the protection of biodiversity, because climate change is bringing in perspectives of just cancellation of species, and therefore the protection of biodiversity then means looking at adaptation mechanisms in both environments and see what are the margins that can avoid extinction and so on. This takes place also in the largest world of polar sciences. Scherr, the next meeting in St. Petersburg, open conference, will be together with IASC, and then I'm sure that tomorrow there will be Colin and Volker will present in the verge of IPY what is the importance of these things. But I think that it may be appropriate in this audience to point out how important it is to get synergies between the two polar systems, taking the IPY as an occasion. It would be a shame in a way that polar research, Arctic and Antarctic research, is being carried out at very high level, both qualitatively and quantitatively, and it would be a pity to miss the possibility of having a very strong synergy between the two.
Thank you. Are there comments? Carl?
Guido, I fully agree, and none of us really had time. We wanted to leave time for this discussion to talk about the bipolar aspects of particularly the life sciences research, but also the climate research. And if I could just quickly respond to Olaf, not respond, but comment that I think maybe in establishing the observing network, one could think of two pieces taking place at different times. One is the research community getting its act together, and then over time, and that's the bottom-up process. And then over time, the top-down process would be through the WMO, for example, the WMO organizations, that have to be operated by government, that are operated by government agencies. They're those pieces of the network. And there will be that transition. Those discussions are taking place, I'm sure, in a number of countries. They are in the U.S. between, in our case, NSF and NOAA about how to work that transition. But I think the challenge this week maybe would be for the research community to really see if it can find ways to move forward and integrate its activities.
One more, Anders, and I think we have to tie this up.
I think just to summarize that leadership, whatever form it takes, and goal is goal formulation are key concepts really. And I think that Savi's comment about the difficulties of getting the data management and organized and running is simply a factor of goal formulation. It's not as easy to formulate a goal around data as it is, for example, around an astrophysics program or whatever. And I think that is something to bear in mind. And also the fact that if you look at the diagram I did, the bottom part of it is easier than the top part. So if you want to see it in a dynamic context, you should move from the lower left-hand corner to the upper right and see this as a dynamic process.
Right. Well, thank you very much. I would say, before I thank the panel, that I think the challenge to the participants of ASSW is to take some of these as we hear about the science, the highlighted science and project day, and then we break up into our meeting groups to address some of these larger issues so that we have a consortium and a forward motion on international partnerships, because that's obviously going to be what we need to have to address some of these big climate issues. So at that point, I want to thank the panel and thank the audience.